Hi friends, very good afternoon to all of you. This session we are going to discuss the solution of a singly reinforced beam. How to find out the moment of resistance of a singly reinforced beam. For this, what are the data given here in the question? You have the question with you. A singly reinforced beam having breadth 250 mm and effective depth 400 mm. Small d, effective depth d is equal to 400 mm, is reinforced with AST is equal to 3600 mm squared. That is the area of the steel given. So these are the data given: breadth of the beam, effective depth of the beam, and the area of steel. So that is the first step. Data given B, D, and AST. That is given in the question. Next, material properties are also given in the question. What are the two materials in the RCC, you know? Concrete and steel. So for the concrete, FCK is given. What is FCK? That is the characteristic compressive strength of concrete is given as 20 Newton per mm squared. So M20 concrete means M stands for mix and 20 stands for its characteristic compressive strength, that is given 20. So you know different grades are there: M15, M20, M25, M30, like that. Depending upon that, we have to consider the FCK values in the design. The next material, the steel, it is also given in the question. We use HYST bars, Fe415 HYST bars, high yield strength deformed bars. For that, the yield stress Fy is given as 415 Newton per mm squared. Right? That is the yield strength of the steel reinforcement. This is the characteristic compressive strength of concrete. Right? So because concrete is very rich to take compression, whereas steel is very rich to take the tensile stress. So these are the two materials given. The properties are given in the question. Now, based on these two, we have to find out the flexural strength that is given in the question. To find out or to compute the flexural strength of the singly reinforced beam. What is the flexural strength? Means the moment of resistance. We studied in the last sum also about the moment of resistance, that is the couple of the two forces, moment of the couple by the two forces, compression and tension, on the two zones, compressive zone and the tensile zone. Here it is compressive in nature and below that tensile in nature. So both having opposite direction into distance, force into distance is known as the moment. So the moment of resistance or flexural strength is to be computed. That is the question. Now for that, the next step, number 3, find out the ratio between XU by D. What is XU? XU is the distance from the top of the beam to the neutral axis. Neutral axis is very familiar to you. We have studied in the last 2 semesters about neutral axis. That is axis at which there will not be no tension or compression. It's a neutral layer or neutral axis. So the distance from the top of the beam to that axis is represented by XU, and D is the effective depth. So the ratio between XU by D is equal to 0.87 Fy into AST divided by 0.36 FCK BD. No need to memorize this equation. This is directly given in your code, Annexure G of IS 456-2000, clause G11. So you can refer that. For the examination also, you can refer that equation. You can copy down that equation from the code directly. Now, Fy, you know the yield strength, that is given 415 Newton per mm squared. AST is given as 3600 mm squared. FCK is given as 20. B is 250 and D the effective depth 400 mm. Substituting these values here, just substitution, 0.87 into 415 into 3600 divided by 0.36 into 20 into 250 into BD. Then you will get an answer 1.308. That's the ratio. No unit for that, XU by D. 1.308 is the ratio between XU and D. Now, as per the relevant codes, there is a limiting value for this ratio for this particular properties of the steel, Fi 415. What is the limiting value? That XU by D is equal to 0.48. That also you can refer IS 456 in page 70. It is given. No need to memorize that value. The limiting value of XU by D is equal to 0.48. Now comparing these two. This is the value obtained from the data given for the beam, and this is the limiting value or the maximum value of XU by D, the ratio. By comparing this 1.308 is greater than the limiting value 0.48. So what it shows? 1.308 is greater than 0.48. In the last session, we have discussed about three types of sections: balanced section, under-reinforced section, and over-reinforced section. What is balanced? Balanced means about the neutral axis, both the compressive and tensile will balance. Whereas in under-reinforced section, the compression zone and the tension zone. So usually we prefer under-reinforced only, because when we design as an under-reinforced section only, we will get a warning before failure. Any RCC member, before failure, will get a warning by falling the concrete from the steel reinforcements. Whereas if it designs as an over-reinforced beam, there will not be any warning. It will fall down very fast. It will fail very fast. So if we got now the value 1.308 is greater than 0.48, usually we will redesign the beam. So here we are not designing, we are just finding out the moment of resistance only. When we come to that section, designing section, we will discuss about it. So 1.308 is greater than 0.48. So we can say this section is over-reinforced. Over-reinforced. So it's an over-reinforced beam, right? When it is less than, suppose it is less than this value, the limiting value, then it will be under-reinforced. So accordingly, we have to use the appropriate formula from the code to find out the flexural strength or moment of resistance. So being it is an over-reinforced section, the moment of resistance for this singly reinforced beam, mu lim. What is lim? Limiting. Moment of resistance is equal to 0.138 FCK BD squared. That also available in SP16 in table C, page number 10. So what is it? 0.138 into FCK 20 into B 250 into D squared, the depth, the effective depth squared, that is given as 400 square. So from this, by solving this, we will get the moment of resistance. It will be equal to, I think it is 410 kilonewton meter. So you will get it by substitution. The unit is in kilonewton meter. First you will get it in Newton mm. Newton, because FCK 20 Newton per mm squared. The unit of force is in Newton and distance in mm. B in mm 250. Depth also in mm. So you will get, first you will get it as Newton mm. Then you can convert into kilonewton meters. You know how to convert it into kilonewton meters? To convert Newton into kilonewton, divide with 10 raised to 3. Similarly, to convert millimeter into meter, also divide with 10 raised to 3. So divide it with 10 raised to 6 total. So you will get the answer in kilonewton meters. That much. Kilonewton meter will be the moment of resistance. That is the solution of this question. The flexural strength of this singly reinforced beam is equal to 0.138 FCK BD squared. I think it is clear to you, all of you, and just I will explain once again about the steps. So the reinforced beam is given. First of all, you have to draw the diagram according to the given values: breadth, depth, AST. Mark XU, the distance from the top to the neutral axis. That is a figure. Then first write the data given, BD and AST. Second, the material properties that is given. These are the two values given in the question. Now the third step, From the code, take XU by D the ratio, this formula that is available from this annexure G, you will get that value, and compare that value with the limiting value of XU by D is equal to 0.48 for this particular steel. So that is from page 70 of IS 456. Then compare this here, 1.308 is greater than 0.48 limiting value, so it is over-reinforced section. When it is an over-reinforced section, the formula to find out the flexural strength or moment of resistance is equal to 0.138 FCK BD squared. By substituting the value, you will get the answer in Newton millimeter, and you convert it into kilonewton meters as the flexural strength. Okay, that's it today. We'll meet again in the next class. Thank you, one and all.